Today we will start the docking of the compound. It can be unknown compound you will using Discovery Studio. Before to that, first step is we need to prepare the protein. For that, we just jump up on the protein data bank. You can see there are n number of the site for the protein data bank, but we open this one. Here on the web server, we are supposed to put the PDB ID. If you have any doubt for the PDB ID, you can drop a message. I'll brief it in the separate video. After that, we need to download it. You can see on the right side there is a downloaded video. After that, we need to open the Discovery Studio software. This is again the freeware software. Generally, I make a video for the freeware software because I feel that if we are good for the freeware software, we can use any software like the paid version. See how the protein look like. It is so beautiful. Fine. You can see water molecules are there, and along with the water molecule, there are the co-crystal, cofactor. You can see on the left extreme, there are the co-crystals, and along with that, they have cofactors also. If you have any doubt regarding it, what are the co-crystal, what are the cofactor, you can drop me message. Generally, I prefer to have a live session on the weekend for clearing all the doubts if you have. Fine. You can see when we prepare the protein, firstly we need to remove them. And here, as it is the Discovery Studio visualizer. Visualizer mean that is we use for the visualizing of the thing only. Here we perform the docking with the help of AutoDock, but in this case we visualize all the thing, whatever they look like, all their cofactor, co-crystal. You can see how the 3D model look like. You can use the same visualizer in your class for the demo lecture and for any kind of workshop. We can make the student understand better, like as the we can discuss the protein structure with the help of these software. They are very helpful. Fine. After that, we need to prepare it. After the preparation of the protein with the help of visualizer, now we jump over to the AutoDock tool. I have already made one separate video on the AutoDock, that is a Python molecule viewer. If you have any doubt, any problem in the command prompt, because in that we need to play with the C language also, I am good in that. Fine, I can help you for that. And I'm also interested for the collaboration if you want to do for the docking, for the drug designing. Happy to listen the problem from your end and love to solve the all the problem or all the issues. Fine. Here we need to uh, add up all the content, ligand the protein. Firstly, I have a protein that is a 3CIFI. That is a PDB ID. If you have any doubt regarding the PDB ID, you can tell me. Fine. After that, we need to choose the AutoDock module. After that, we need to choose the grid. As we know, first step is the preparation of the protein, and the second one we need to prepare the grid. Fine. Here are the there are the different component like number of points in X, Y, and Z dimension. After that, we can choose their grid box also, their spacing also. Generally, it is in the angstrom. You can see on the left side there is a all the things are there. After that, we need to save it by going to the view, and after that we need to save this GPF file. If you have any doubt regarding it, otherwise we can choose the grid as in the center of the molecule, because generally binding pockets are in the center. Otherwise, there is one more web server that again that is for the free, that is a castp, that is used for identify the pocket, binding pocket. Fine. You can see on the bottom grid box is there, or you can directly choose the center on the molecule, or you can define it in the space like how I do. Like when distance is defined in the y center or the x center or the z center, we can choose it like uh, or we can see if the we have the substrate with the protein, we can choose the protein with the substrate. After that, we can extract that substrate and on the same side where substrate they are supposed to bind, we can choose the same side. If the substrate are not available, we can choose the binding pocket as the random method. Fine, that is in the center of the molecule or the side of the molecule, or we can choose the binding pocket with the help of ligand interaction diagram. Again, if you have any doubt regarding the ligand interaction diagram, you can drop a message. I love to clear the session on the PDB sum. In the PDB sum, we have ligand interaction diagram and we can solve the same problem with that. Fine. Now you can see everything is within the protein. We can add the hydrogen bonds polar and we can remove the water molecule. If any water molecule, that is exception, sometime water molecule they also play in the role for the interaction. Generally we need to consider the hydrophobic, hydrogen bonding, hydrophilic interaction. Fine, sometime water is also play an important role to have the hydrogen bond interaction with the ligand. Fine, in that case we need to preserve that hydrogen bond or water molecule. Otherwise it is a desirable to remove all the water molecule. Fine, now you can see everything is in the molecule. Fine, after that uh, we can directly define the dimension, or you can see the grid box center spacing we can design, and generally we keep this spacing angstrom distance is a 0.375, or we can choose this is for the default setting, otherwise we can change it also. Fine, this is all about the method of preparation of the protein. After that we need to save their value. Again, go to the e lead 3D, that is they are used for the drug designing for the screening. Here we can like in this case we take the database for the docking. Fine, here we upload the protein which we prepared with the help of AutoDock. Fine, and residue we need to mention the residue binding pocket, whatever we choose from there we need to mention the same. Fine, submit it. Here firstly we need to choose the protein and the ligand separately. Fine, with the help of lead 3D. As I told you, I'm happy to do the thing on the freeware web server software. If you have any doubt, love to listen the problem. Fine, here we do the de novo drug design. Fine, first step is method of preparation of the protein, second is preparation of the grid, and third one is we need to prepare the ligand. Here we draw the ligand, prepare the ligand molecule. Fine, here if you are beginner you can start with any molecule. Find random molecule, small molecule, not for the big molecule. After that we can uh, the same web server, this is for use for the de novo, since de novo designing also and the virtual screening also. We can do the virtual screening also and we can put your our email ID there. Fine, now you can see everything is there. Fine, everything is molecules. You can see on the left side compound is there, and these are all database that are we screen with the help of virtual screening. Fine, here are all the databases there along with the details of everything. Today I keep the session very small. Next time I thought to have 1 hour long session for the same, where I explain everything in detail one by one. Fine. You can explore this database and have the session in your class. If you are teacher, if you are the student, like in this manner, we can you can see we can screen the natural compound. Now, as nowadays it is in the trend to work on the natural compound rather than on the synthetic compound, so we have the natural compound. You can see this is that database, that is a chem informatics tools and database for pharmacology. As there are the number of the database today I just keep this session very simple and the small only, so we choose only one compound. Fine. And even roots are also defined. After that, again with the help of Discovery Studio visualizer, we visualize this. Macromolecules we can define. Choose a macromolecule. See, the compounds are in the pocket of the protein. Here there are the different ligands within the pocket of the enzyme, or we can choose one or more. One by one we can choose it. Fine. I hope this session is useful to you. If you feel really videos are good, please do not forget to like and share. Thank you so much. Stay blessed. Happy learning. If you have any doubt, do not hesitate to approach me. Enjoy with the PDB today. Fine. Because whenever I feel time, I don't want to spend time on Instagram. I prefer to work on the PDB. Here we have January molecule of the month. In the next video, I'll explore this compound, January molecule of the month. Happy January ending and love to start with the February. Thank you so much. Stay blessed. Thank you.